Welcome back to the Talking Ball podcast, powered by Arbitrade. My name is Tom McCluskey, and today we're coming to you from the Red Bull Technology Campus to talk all things 2026. Now, if you can hear a bit of noise behind me, it is because the team are working flat out to get things ready for the brand new 2026 season. Today, we are speaking to 6 members of the team from systems, electronics, materials, and of course, power unit to break down what is changing and why it matters. Now, to kick things off, I'm joined by Pip Clode and Akina Egawa to chat Oracle Red Bull Racing's very first in-house power unit, of course built in partnership with Ford. Pip is head of powertrains here, overseeing 6 teams across both internal combustion engine and hybrid systems, and has been part of the project from the ground up. And Akina is head of program management, looking after the entire journey of the power unit from R&D right the way until getting everything ready for the race circuit. I started by asking Pip and Akina how they are feeling about 2026.
I can't wait to go racing. Absolutely cannot wait. This is the longest period in my whole career that my product hasn't been on track.
Really? Yeah.
So I'm just itching to get it out on track. I can't wait.
I can imagine.
Exciting, it's exciting, but nerve-wracking time, isn't it? It's everybody's excited, everybody's keen to go to the race grid, yeah.
And the anticipation, because you're putting your baby out there to the world, this thing you've been working on, but also the anticipation is that power unit is going to be a massive performance differentiation between teams with so many power units as well. Obviously, you've got Audi coming in, you've got Honda with Aston Martin, we've got Red Bull Ford here. Have you spoken much to your fellow engine people in the other teams? Do you have much of a sense of what's going on at the other teams, or are you very kind of cocooned into what's going on here?
You hear rumours, but I've been in Formula One for 20 years, and I kind of learnt to ignore those. You don't know where anybody else is. Nobody knows where they're going to be when they hit the track in 26. So it's more a case of you hear them and they're kind of interesting rumours, but you just need to keep your head down, keep pushing. Yeah. Do the best that you can, get everybody around you doing the best that they can. Yeah. That's all we can really do.
It's also important to not being distracted by the rumor, so we need to keep our heads down, as Pip said, and we need to chase on our path what we believe, what our engineers brought to the table, and then make it real and then make it achievable. And then I think that's quite important things. We hear lots of rumors, and then obviously the FIA has a power unit working group, so we get some feedback from various teams and the FIA itself, but again, trust what we do, keep heads down.
But I think when we first started 3.5 years ago, we kind of laid out the route that we thought we needed to take to get to 26 and be competitive. So we had milestones and we had targets along the way, and I think we've just been very single-minded on making sure that we get to those targets, get to what we thought was going to be competitive, and keep pushing to that and not being distracted by the rumours that you pick up.
Has that been a challenge with so many iterations to the regulations are now signed off, you all know what you're working to, but it's not like it just happened overnight. These regulations were announced years ago, and with the 50/50 and the ERS deployment and all of these different things have changed. Has that goalpost moving made your job? Have you had to chuck out a load of work because now that's out of date, or how does that work?
Well, other than designing the building when I turned up, I was also on the committee working with the FIA to define the new regulations. Okay. So I got to see them before they were officially released. And the important thing for us was to try and reduce the advantage that the incumbent power unit manufacturers have. So they already have technology that they've been developing for decades or longer. And we are completely starting from scratch. A new building, new people, nothing existed. So a lot of what the work that we did was to try and reduce that advantage that the incumbents have. So the regulations, that's the playground that we work within, to be honest. Are not particularly daunted by anything in the regulations. It's just what we work with and what we play with. But it was just making sure that Red Bull Ford powertrains could turn up and be competitive in the first season, which is what we're aiming to do. And
also, I guess the responsibility of the teams is to yourself to bring performance, but also the responsibility of, I guess, the FIA and the rule makers is to create an F1 that is close wheel-to-wheel racing, minimum dirty air, good, not too much differentiation power unit wise. Do you feel confident that 26 is going to start with a bang, or is it going to be, at the start of most regulations, we get a big spread of performance? And I guess it's impossible to know, like you said earlier, like how all the other teams are doing. Do you feel confident that F1's going to be like super close, because you've got two teams running this Red Bull full power unit, of course, with two teams here. Where is that as a fan, I guess, more so than someone working within a team?
Well, I guess stability in the regulations is usually where all the development curves have become shallow, and then you end up with a lower differentiation between teams at that point. What's unique about 26 is that it's a complete tear-up of the chassis regulations, aero side, and a complete tear-up of the power unit. And doing those two things at the same time, I can't remember that being done.
No, it's a long time, isn't it? Yeah.
So everybody has a very steep development curve at the moment, and depending on where you are on that curve, you could be a big performance differentiator, positive or negative.
I think that makes more interesting and also important for our relationship with the chassis side, because now we got to one company, one team's doing chassis and then power unit first time ever for the Red Bull. So that's definitely the benefit to go for the new regulation, because we can merge two-factor quite tightly. So this is definitely the exciting moment. And then
it's one of the things that's so exciting about the whole project of having powertrains and chassis side by side on the same campus. It's a 5-minute walk from my desk to go and talk directly to the guy that's designing what I'm interfacing with on the chassis side.
Yes.
And we have to be able to turn that into a performance advantage.
Yeah.
And right from the start, when we were working on these regulations, we were talking directly to the chassis guys to say, what do you want? And I think one of the tricky things was the chassis regulations were defined so much later than the power unit regulations. True. So a lot of the times the chassis guys were struggling to give us direction on what do they want and where are their regulations going. But the fact that we were in such close and regular conversations about what we might want and what we can do on the power unit side to give the chassis side more options depending on which way the regulations go, I think that's a big. That was the exciting part of the project, being one entity all close together. But also should be a big advantage when we get to 26 and beyond.
And obviously the PU is going to be so imperative to this. Again, it's probably going to be the key performance differentiator at the start at least. How do you manage, I imagine you've got systems and electronics and materials and mechanical all approaching you, asking for things, and because the PU is the core component, I think, now in this regulation cycle, maybe more than ever. How do you decide what to prioritize, I guess, and how to balance all of these demands coming from all these different departments who, the PU is absolutely core to all of them, but you need to designate your time as well, right?
I think that key things is to share the same goal among the older team member. So that's kind of like a responsibility for the project management team and the program management team that I belongs to. So we map out the roadmap for how to get to the 26 race. And then from back in 2021, 2022, we mapped out all the design activity and R&D activity and how many iterations we can squeeze in that limited time, and also make sure that everybody's aiming for the same goal. So the priority is one thing, but we also, we can't move the goalpost. 2026 race day doesn't move. So we share in that same target, and then what we need to achieve on each key milestone, we share all the views and then goals among all the departments, and then we were working towards that. So that was definitely a big collaboration. And company itself, Red Bull Powertrains, started from, again, 10 people to now hundreds and hundreds of people.
It wasn't an easy task aligning the chassis and the power unit programs when the regulation timing was so different.
Sure.
Our development cycles are so different to the chassis side. It was a big challenge to figure out how to align them and how to align on decisions when actually your decision points are so far apart. It was tricky.
And also the unknowns. I asked this question. We had Lauren on the podcast recently, and I said to him, how do you set goals when it's so unknown, because you don't know? It's a relative game. F1 always has been. How do you set performance goals with the power unit when you've got no idea what you're going to be up against as well. That must be so difficult.
One of the beauties of being an engineer in Formula One is that we work from first principles, from the basic physics. So that's where we start. So we have the new set of regulations, and you say from the fundamental physics, what would be a good target? We have experience of current power units in the business, and being a new business, we have people bringing in experience from all over the industry and outside of Formula One, which is again another opportunity that we hopefully have capitalised on. But we start right from the physics, right from the base, to say, knowing the performance that we get out of the current power units with the physics that applies to those, where do we think is going to be competitive for 2026? That's where we start.
I think it's got to be a balance as well, of course, between performance and reliability. Start of 26, brand new engine, years of work's gone into this across all departments. At the start, do you anticipate that teams are going to build in a fairly large margin of error to preserve reliability, or be a bit more risky and push the envelope a bit and hope to gain a bit more performance, but risk power units kind of conking out in the early races? These things, I guess, where there's so many unknowns, how do you as a organisation set that level of risk, I guess, Akina? What would you say?
I think it's about getting the targets right at the start. It's about having the clear vision of the reliability is relatively easy to target, to come up with, because we know how many races they're going to be a year and how many power units we're going to have a year, how many of each elements we're going to have. So the reliability requirement for each of those you can set quite early, and it's robust and doesn't change. The duty that the power unit needs to survive within that mileage, that's a variable, and that's something that as your performance evolves, so does the duty that everything needs to survive. So you kind of need to continually evolve with the performance of the power unit. We knew where we were expecting to get from performance, so we also kind of knew where we needed to be from reliability. One of the big challenges for Red Bull powertrains has been we have no reference and no baseline.
Yes.
So especially on the internal combustion engine side, the regulations kind of fixed the V6 to be very similar to what's currently racing, but they have less fuel, so less load on it. So from that you can inherit, or the incumbent power unit manufacturers can inherit the reliability for what they're currently racing. We had none of that, which is a challenge and an advantage. So we had to design everything. So there was nothing that we could bring forward from an existing power unit. We had to design every single nut and washer, all the way up to crankcases and cylinder heads.
That's the biggest challenge for us. Everybody
had to design everything right from the very, very start.
Yeah, exactly. So from the facility, as Pip said, testing rig, we didn't have anything. So everybody brought their ideas and what we need to have, what facility, what room setup, what tooling, what simulation model, what sort of software we need. We started from the scratch for everything. So that was absolutely big challenge for everyone joining the company.
The regulations give a small financial step up for newcomers, but it doesn't go any way to covering what the actual increased overhead for being a newcomer has been.
I can imagine.
And that was possibly the thing I underestimated the most when I joined this journey, is just how much groundwork we needed to do before you could do all the bells and whistles bit. And a lot of what the incumbents will be doing is the bells and whistles and the nice bits of finding performance and retuning, and we had to start right from the very basic washer and nut.
Let's talk about the 5-day test. End of January, big day, behind closed doors, all very hush-hush, very secretive, but I'm sure you two will both be right in the thick of it. What's the deal? Who's going to be trackside? Who's going to be here? Akina, have you got a plan for the day at this moment, or is that still a bit too far ahead?
We have some, we need to hit the milestone. Like, we have a delivery target, and then we start talking to each team, like what equipment we need and what equipment we need to supply. So that's ongoing discussion. So we get into the real, like we start looking at the trackside operation, which is exciting because we always focusing on, we sort of had the luxury to focus on the R&D activity in the last 3 years, but now we need to shift it to the race team, which is real. And we also thinking about 27, 28, 29, because R&D doesn't stop.
No.
So we're also looking at race 1, test 1 for 26, which is exciting. But at trackside facility, I'm not on the track side, so I will support from the office, I'm sure.
One of my teams deals with the integration of the power unit into the chassis.
Sure.
So I would really love to be there and as close to the action as I can get. And like you said earlier, this is our baby. This is something that we've been working on incredibly hard with an awful lot of people pushing really, really hard for what will be 4 and a bit years by the time we get to the track test, and I'd love to be there at the point at which it leaves the garage for the first time. If not, I'll be at home watching it, or in the office,
trying to find the spy
in the
shots.
office, watching the data come through and making sure everything's where we expected it to be.
Well, I guess you've got to strike that balance between looking at your own data and your own insights and understanding this engine that, again, you've worked on within the facility but not actually had in the race car until then on a live track, but also, I guess, looking at what everyone else's power units are doing. Like, I'm sure that's going to be a degree of it, right? And we always see this with people with their cameras walking around looking at other cars. Like, what you can learn even from like the sounds of these engines and just the way it's packaged. I imagine that's also going to be an important part because, like we said earlier, it's a completely relative game. So you need to understand what everyone else is doing as well, right?
Yeah. So for the 26 power unit, we've lost the electric motor that's in the turbo, and that did. Other than harvesting energy, it also dealt with turbo lag and managing turbo speed. So we don't have that facility anymore. It's taken out of the regulations. So the energy management and the strategies to control turbo speed and harvesting energy, where you do that and how you do that, is going to be a massive part of being competitive and strategies for 2026. So we will definitely be watching to see whether, I guess the biggest risk with the new set of regulations is that you've missed something. Sure. There's something in there that you just not appreciated the potential in it.
Everyone else is going to feel the same.
Oh yeah, it's unknown unknowns at this point. Nobody knows they've got an unknown. It's all unknown unknowns.
I imagine, because Rebel Powertrains is a very new engine division. Have you got a gist, an idea of what your fellow engine workers across all the other teams are going through? Like, you're going to keep your cars close to your chest, of course, right? But you must be strategically trying to work things out of people you've worked within this paddock, particularly you, Pip, obviously been in the sport for so long now as well, right?
Yeah, I think we don't know how everybody else has got. We just like the rumours, like we were saying earlier. We have rumours, but we don't know. But
we need to know. So we have people keep asking the questions.
Well, we would like to know what the other competitors doing.
It'd be a couple of months to wait from the time we're recording.
It'll become real very, very soon. But I've got all this grey hair by having done new engine introductions quite a few times in Formula One, and it's the challenges when you're introducing a new power unit are similar. The complexity of the 2026 power unit is similar to the 2014 power unit.
Yes.
So all the worries and the concerns and the grey hairs that I got at that point, I'm getting more of them now. Oh yeah, it's definitely worth it. What a silly way to make a living, being in Formula One, right?
Absolutely. Can we, Akina, can you explain a little bit more about the 50-50 split? It's been talked about a lot. A lot of concerns early on when these regulations were announced. A lot of talk around, cars having to lose power at the end of straights because they run out of battery, blah blah blah. There's been things implemented like the derating on the electronic component. Where are we looking right now? Are we confident that these engines are gonna, down the straights of Baku and Monza, that drivers are going to be able to keep it floored and these cars are going to be quick?
I think it's similar to how the chassis side optimized their design. So we have a simulation and we have a computational model. We have a department dedicated to the controls and the track side of performance. So they're spending quite a lot of time looking at the lap time optimization. We also run those tests in simulation basis and also dyno basis. So all of those learning curves are brought into the track side of performance and the strategy. So when we get to the track side, our PU performance engineers and then hybrid system performance engineers feed back that information to the race engineers on the pit lane and the garage side. So we have a close communication and the collaboration between chassis side and the PU team. That's going to enhance our overall car performance on the track side. So we are spending lots of time looking into how can we optimize our strategy, how we can optimize the design based on that conversation.
Yeah. Do you feel like the simulation tools you have, obviously you can never fully replicate 100% real life, but I guess as these tools have improved, just from a technological point of view, that you feel pretty confident that you're not walking into too many unknowns, I guess, from that point of view, in terms of, again, engine running out of steam down the straights and that kind of...
On the power unit side, we have the luxury of being able to run our engines, physical engines, in a dyno and do lap replays. Mm-hmm. So we know really quite well how our engine is going to perform and operate and what's good and bad about it at the moment, and that drives our development and what we change. The chassis side, they have the wind tunnel. So again, we get really good feedback. We have very good simulator capabilities here at Red Bull. Again, one of the advantages of us being next door is that I've got to see the simulator, which normally you wouldn't do if you're just a power unit manufacturer.
True.
So we're getting driver feedback. But the 50/50 regulations and the lack of the MGUH means that there is a bit of a shortage of energy on the car, and that's driven the aero regulations to have the variable aero front and rear, which is all part of the energy management. What that will bring, though, is very big differences in strategies and in opportunity for the driver. So if the driver decides to keep the MGU-K turned on, he has 350 kilowatts more than the person who has the K turned off. But he's going to have to pay the price when he gets to the next straight, and he hasn't got the energy. So it could result in really good racing with a lot of changing and a lot of speed differentials between cars. And it's down to the driver to deploy what we give them. So
it's an additional challenge for the drivers, for the strategy teams to manage this extra. I mean, of course, we have battery deployment now, but not to the same extent, right? Also, briefly want to ask, obviously Ford involved heavily now with the engine project. Practically, have they been super hands-on, Ford as a partner? They've
been a great partner, really great help. Right from the very start, they kind of said, if there's anything that we can help with, just ask. And they've never failed to pick up the phone. Any time we have something that we think, have you got any expertise in this, they'll go and see whether within the Ford empire, whether there's anything that they can do.
It's
and right at the very start,
before
we had any buildings, we had a turbo but nowhere to test it, and then being able to say, have you got a facility where we can test a turbo? Amazing. And they can step in and help. So they've been a really great help any time we've asked.
Great.
It's been good. Really good partnership.
Good to hear. It's not just, because I think Ford's legacy in this sport is actually huge when you look back, especially from a PU point of view. DHV was powered many a world champion. We've got some listener questions.
Okay.
That's a wrap up. So, Alexia from Belgium asks, how do you see the future of Formula One?
Good question, isn't it?
It's a great question.
The future. I think medium, long term, perhaps?
Well, the 26 regulations have got the sustainable fuels. And that, I think, is a future direction for road cars, let alone Formula One.
Yeah.
And I think having sustainable green fuels and the work that we've been doing with Exxon to develop our fuels for 2026, if that carries on, it opens up opportunities in the future. So I think the increased use of sustainable fuels, and then maybe moving back towards more in terms of the internal combustion engine power against the electrical, could be a direction that they go in. We'll see. Anything come to mind, Akina, outside of that?
I mean, it's interesting question, definitely, because as a motorsports fan, I've been watching F1 from early 90s with my dad. He was a big fan, and Senna time and then Prost. It's a big change in last 30 years, and personally I start driving electric car, so definitely electric side probably start playing a bigger role, but as a F1, as a high-end engineering sport, I think current, whatever the form it will be, the current combustion engine and then hybrid system will stay quite a long time as an exciting sports field, I think.
And I think that's kind of always been a part of Formula One, its connection to real road, or not even real, just real industry outside of the sport.
Yeah.
Even just road relevance, right? In aerospace, in so many different areas. And I think sustainable fuels, that's a big one. It's very exciting, the work. I know Paddy's been doing a lot of work, hasn't he, with the sustainable fuels thing. So I think there's a lot of room for innovation there. Adriana from Serbia asks, how would you compare the processes of integrating a supplier's engine into a car, as with Honda previously and existingly, versus building your own engine? So the specific differences between that.
It's the level of interaction.
Yeah.
So when you're a customer team, the engine is defined by the factory team, and then within the regulations, there's a small number of parts of the power unit that you can have different between the two teams, so you can make that specific to your customer team. But the engine is really defined by the factory team. And with us being one entity, Red Bull chassis and Red Bull powertrain, the chassis can have as much involvement as they want, and we want them to have as much involvement as they can on defining what the power unit needs to be in order to make a better car.
Yeah.
So you try not to have a trade where you can have a fast power unit or a fast chassis. We'll work together and we'll have fast both. And that's the opportunity. That's the plan. That's what we have to be aiming for.
This conversation can go on for so much longer. I have so many more questions, but we are going to wrap it here. Pip, Akina, thank you so much for your time.
Thank you.
Thanks for having us.
Good luck for Jan.
Thank you
It's
very
going to be
much.
intense. It's going to be fun.
Yeah.
Can't wait. Can't wait. It's going to be brilliant.
Right, let's talk systems and electronics, shall we? Two parts of the car you might not be so familiar with, but which are going to be crucial in 2026. I can assure you that. To get into it, I'm joined by Chris Finister and Paul Everington, who have between them over 40 years experience at Oracle Red Bull Racing. 40 years. Chris is the head of systems and looks after the design and integration of the chassis systems, from everything electrical to packaging, cooling, the fuel system and power unit integration. And Paul is head of controls, overseeing everything to do with on and off car electronics. It's a pretty sizable department covering design, manufacturing support and the full operational side of the electronics on the car. They've both worked through many regulation changes during their time at the team. I started asking if anything about the jump to 26 has been uniquely challenging.
I think for electronics that it's the wholesale change across the whole car. So whenever we've done an electronics change, you're normally stable in one of the other areas. But this year, or this time round, it's been change all the way through.
Okay.
So starting from understanding what the PU was going to be, then working out what the electronics needed to be to support that, and then moving into the chassis regulations, it's just continual change. It's the biggest one I've ever seen.
Chris, where you're working on, systems, Paul on electronics, are you often working together? At what frequency are your departments intertwined? And is that, which departments are you working with the most relative to your own?
Yeah, we work really closely together. We I was just saying the other day, if you were to, for example, if you talk about the chassis looms, how much of our group's resource goes into that, it's probably similar to your guys' resource going into that.
I mean, all day and every day, the electronics guys are working with Chris's systems guys. And electronics is interfacing with all the other areas in vehicle design as well. Not just vehicle design, aerodynamics, vehicle performance as well. So we're sort of spread across everything.
And obviously bringing the engine in-house for the first time in the team's history, how much of a difference has that made to your respective day-to-days? Is it easier working with a in-house PU versus a customer supplier deal?
I think yes, but it also brings a different challenge, because you, instead of being told what you're getting, there's an element of working together to understand what is the best for the overall car. So it's definitely different. So there's a different way of working when you're part of the product, not just getting the end result.
Sure.
So normally we would get a load of documentation, a load of CAD, a load of specifications. We're now part of it. We're now working out what goes on the PU, what do you need, what do you want to measure, what do you want to install. So it's a big integration package.
Yeah.
Certainly longer term, I think that's going to be a massive benefit for us as well, is being able to have that, that partnership on site as well, on campus. That's something that shouldn't be underestimated. But yeah, you've got new people to kind of communicate and understand their point of view and perspective. So there's a growing of the relationship that's that needs to be worked out as well. But yeah, certainly longer term and looking forward, that's I think going to be a big benefit.
Yeah,
for us.
I mean, if you need to go and bug someone, you can walk 300 foot up the road and knock on their door and say, "Excuse me."
Yeah, it's definitely better in that way for the communication. Yeah, so as long as you can get the right people talking together, and as Chris says, it's taken an amount of time as Powertrains has been building to get the people involved, and still now we're still trying to work out the correct level of communication and the right guys to who should be speaking to who.
And 2026, from a fan perspective, I think there's three big numbers really that I think are exciting from the 10 centimetres narrower, 20 centimetres shorter, 30 kilograms lighter. Do those parameters affect your departments in a significant way, would you say, Paul?
They do. I mean, it affects Chris more than it affects me, because we just have to package what we have to package, but Chris has to make it fit. And I think that's the big problem, is that this car has got, from an electronics perspective, it's got more boxes, it's got more wiring than any car has. So Chris has got to work out how all that gets installed.
Yeah, I think it's the kind of the consequences of those changes. So the track change and the wheelbase change, that doesn't really have a big impact on us, but the aero changes and the regulations and the sort of the squeeze of the aero shapes and everything that we've got to package within that, that does have a big impact. And as Paul says, there's the FOM changes alone are a massive change, and it's certainly been a challenge. But ultimately, what we're trying to do is we're trying to deliver the best packaged car. We're trying to get the best performance car, but also we're trying to give the aero group probably the best potential for development going forwards.
Yeah, I guess that's a big part, because you look at how much the kind of coefficient of downforce improved from the 22 cars, look into the 2025 cars, and now I guess you're having to set a template, a base, a foundation that can then be grown on and iterated over we've seen, look at the step, McLaren are a good example, the step they made within these current set of regulations from being right at the back to right at the front. That must be, I guess that's a consideration right across every regulation you've worked upon. Do you feel like in 2026 there's more, less? Is it impossible to tell how much viability you will have to innovate and push these cars forward?
One of the difficult things from an aero perspective this year is that nobody was really allowed to work in anger on the 26 regs until the start of this year.
True.
So in terms of maturity of any of the philosophies, then they're not that very far advanced, and we're setting architecture of a car around that. So there could be some mistakes. There could be a big spread across the field depending on the philosophies people have followed. If you were to look at our launch car, for example, you might not think that everything has been packaged maybe as well as it could have been, but we've tried to do it in a way that gives the aero group in particular the most flexibility going forward.
Compared to when you both started in the sport, the cars were a lot smaller back then, but I imagine it's, correct me if I'm wrong, but you're trying to fit a lot more technology, a lot more stuff into, these cars are smaller, they're still a lot bigger than they were back in the mid 2000s, but there's just so much more to factor in. Does it mean, I guess, is there more to go wrong? Because these cars seem to be more reliable than they used to be back in the day, but is that a product of just innovation, CAD tools, all these systems getting better at making sure these cars don't break down?
For sure, 20 years ago the cars were a hell of a lot simpler. If you look at the RB1, and when we ran that a year or so ago, when you look at that, it's such a simple car. But the rate of development and the tools that we used were nowhere near as established as they are now. So because you were sort of allowed to fail a little bit because of the way you tested, so you didn't need to push your testing more into the factory, you could do it at the circuit. Whereas now there's a lot of development and a lot of work done prior to the car being built to prove that they're all going to work and succeed. So from an electronics perspective, we bench test everything before it even goes anywhere near a car, and we've already done that on next year's car now. So we're sort of, you try and prove everything to a higher detail than you would have done 20 years ago.
Yeah, and I guess obviously 20 years ago as well, unlimited testing. You'd have test teams who were pulling crazy shifts, and you didn't have the cost cap either. So I imagine that makes a big difference.
You had a lot less people, a lot less people.
True.
One thing that's probably worth pointing out as well is that the size of the car doesn't necessarily indicate the available packaging space within it as well. So even in the current regs, the packaging of all of the systems that we need to fit on car are incredibly challenging, even though the cars seem visibly so much bigger.
And obviously for you both, in terms of the opportunities to kind of take risks and push the envelope, where do they sit within systems and electronics? Is it more of just a simple packaging thing, trying to make things lighter? Are there other ways you can, respectively, Chris, you can innovate within systems?
Yes, there are, and I don't know, the technologies certainly on this set of regs for systems-wise are not in themselves particularly challenging. The challenges are a packaging challenge and probably a weight challenge.
Sure.
The innovations really, for me, that comes from giving the people within our group the freedom to go ahead and innovate, have their own ideas, try things.
Which I guess in the cost cap era, is that more difficult to justify, I guess, at times?
Taking risks.
You've still got her, haven't you, right?
Yeah, you do.
There's an element of balance that you have to do. So, like Chris said, you need to give people the freedom to allow them to innovate and to, there's a lot of scheming goes on in the background. Definitely between our two groups, there's a lot of scheming where there's ideas are shared, and then we try and close all that in. From an electronics perspective, there's a hell of a lot of standard product now, so you don't really see a lot of electronics innovation because of standard ECU, a lot of standard instrumentation. So our world is about how we can best package it and best install it.
I've got some listener questions for you both. Listeners kindly submitted, so thank you for submitting the questions. Liana from Canada. Best car ever, go, go, go.
From a Rebel perspective, it's got to be the 2023 car. So, that's an obvious one, isn't it?
Unbelievable.
Yeah, that's a good shout. But probably favourite one for me would be first win. So that would be our B5.
Great car. Those cars back then, aesthetically, I think they were stunning back then.
There were some really, really cool innovations in that set of regs. I think I've really fond memories of. Well, is it fond memories? ERS, when ERS first came around?
Yeah. It was a late night challenge.
Yeah.
Quite often.
And I guess that kind of innovation was a bit more no cost cap, less rigid restrictions on the rules, I imagine, as well, in terms of the freedom. Even if you had the money, you could also do more with it, right? And we're less restricted into what you could put time into.
Yeah, definitely. I think that, again, that sort of V8 era, there was quite a few innovations, double diffuser, and that went on for a couple of years, and that really was getting out of hand.
It was.
F-duct.
Oh, that the hand.
Yeah. But they were amazing solutions. Yeah. And really fun to be part of as well. Yeah.
I'm waiting for the 26 spec F-duct. We all are.
Who knows?
Never know, maybe. Bas from the Netherlands asks, what is the one thing you wished you'd figured out earlier on in the 26 development cycle?
I think how challenging the new ECU was going to be, and whether we could have done anything sooner. We're still learning. We're on the dynos now. It would have been great to do that earlier. But you can only do with what you're supplied at the time. So
in hindsight,
yeah.
I think I would prefer that we'd really understood how difficult it was going to be a bit earlier on as well, and we'd have probably taken some time to get ahead. But the thing is, you don't know until you're in it, and getting ahead is difficult to put in the extra time when you don't know you're going to be behind.
Hindsight's a beautiful thing.
But then
right?
when you are behind, you wish you had.
And you know full well everyone, all the other teams is feeling the exact same emotion.
Absolutely,
for sure.
Because it's such an unknown coming into. That's going to be so rewarding as well. I'm thinking, 3 years, 5 years, you've been working on these regulations to finally see those cars. I reckon that'll feel a bit of pride, right, when they roll out.
Yeah, it's nice to get the stages completed because you're on the right track. So, like I say, the test that we were doing a few weeks ago, when you do that, you've made hopefully a lot of the right calls.
Sure. Yeah.
And you can then very quickly move on to the next stage.
Paul, Chris, thank you so much for your time. Really appreciate it.
You're welcome. Thanks a lot.
Thank you.
We're excited to welcome AvaTrade as a presenting partner of the award-winning Talking Ball podcast. Now, AvaTrade is a globally regulated, multi-award-winning broker featuring over 1,250 tradable instruments from CFDs and futures to options. With trading platforms like MT4 and MT5, as well as their mobile app or web trader, AvaTrade is built to empower traders to trade with confidence anytime at every level.
And finally, we're diving into design with Rich Pratt and Ed Aveling. Now, Rich is Deputy Head of Composite Design, which make up a huge percentage of the car. Chassis, bodywork, the wings, gearbox, casing, all of that comes through his department from a design point of view. And Ed is the Chief Designer of Mechanical, looking after suspension, transmission, hydraulic systems, cooling layout, electronics layout, and a chunk of the R&D project work as well. He's been here 25 years and has seen more regulation cycles than almost anybody else. I started by asking the guys what stood out as the biggest shift compared to the regulations they'd previously been working on since 2022. So, of course, 26, the cars look very different. We've all heard the top line numbers, 30 kilos less, the changes in the dimensions. But for your department specifically, I guess what's the biggest change compared to this current set of regulations we've had from 2022, this new set of regulations from 26? What's the biggest difference in your respective departments? Perhaps starting with the kind of composites. Material side of thing.
Yeah, well, funny enough, I guess putting the materials to one side, just the fact there's a new power unit, a new power unit layout as well as actual new provider. So the rear part of the chassis is heavily involved in that. To integrate with the unit itself. So that's probably one of the biggest things. And then aerodynamically, the floor component is very different. That's not something that necessarily needs 12 months of us developing or anything like that, but it's certainly, that's where we are right now, looking at some of these structures and thinking, okay, we need to sort of make sure it doesn't fall off, some of it first and foremost, and make sure it doesn't. That's helpful, and some of it is a challenge, but and then on the back of that, of course, you just mentioned the weight there. That's always. Yeah. The last time we did a sort of new set of regs, us and quite a lot of other teams, we were quite overweight,
Yes.
So that's sort of very much still there in everyone's mind that whatever we do, we want to try and be as efficient as we can.
Of course.
Yeah, I think the biggest change for all of my groups were the new power unit, much bigger battery, much bigger MGU, putting the energy back into the rear wheels electrically. So it required buy-in from all PU manufacturers to change the stud pattern on the front of the engine to mate with the chassis, to make room for the bigger battery packs and the MGU unit. So it kind of started with the engine integration almost and the requirements of that.
I'm just remembering back to 2022. Correct me if I'm wrong. I think it was Alfa Romeo Sauber were the only team who were really close to the weight limit at that time. Everyone was kind of overweight at the start. Are you expecting that to be the same? Because, I imagine you develop these parts, you're trying to bring as much innovation as possible, but then you're obviously safety parameters, you want to make sure you're not cutting off too much material, that you're shaving off grams here and there, but that takes time, right? So are you anticipating that most teams are going to be over that weight limit to begin with and then gradually iterate towards it, as that has been the case in this current regulation cycle?
I think that's a fair point, yeah. I think, or certainly whether they are with respect to the weight limit, I don't know, but you're right. I guess there'll be a starting point and then it'll come down, just like it has done now. Once you have that confidence that what you've designed is where it is with respect to the limit. Maybe you can, with each iteration that you do, you always take a few grams off, but you never I guess you never have the nerve or the confidence to start off at that point. You're going to start here and then chip away at it and get there eventually. But with respect to the weight limit, I don't know. I guess like us, it's very sort of fresh memory of weighing the car for the first time and realising that, crikey, that's a lot heavier. That's a lot heavier than I think people were expecting. So yeah, and we certainly keep control of the weight. I don't know if it's better than it would have been 5 years ago. I don't know, but there's a lot more communication about it over the last however many months, really. Isn't it?
I think with the 2022 cars, there was a lots of new rules regards to where the downforce was coming from, like with the floors, having the floor tunnels and everything under there, and we weren't too sure where the ride heights were going to be, so we had to put a fair bit of contingency in there because the car may be touching the floor where we just have not been touching the floor in the years previously to that. Whereas I think hopefully with this car we know a little bit more, as in it won't be running hopefully as low as the current cars, maybe not quite as high as the previous generation before that, so we'll know hopefully a bit more about where it's running and not have to put in quite so much contingency as we did with the 2022 car.
And obviously you've both been at the team for over 20 years respectively, so you've seen so many different changes in regulations. I mean, these cars back in 2005, so much smaller, so much nippier. Then you had the insane barge boards of the 2008 cars. It's gone through so many different changes over time. Where do you, just I guess personally, just as much as fans of the sport as you are, employees working within this space, what kind of racing do you think 2026 has the potential to give us? And there's been a lot of, and we don't know until we see these cars, right? In certainly Barcelona, behind the scenes testing, but also, of course, in Bahrain. Are you confident that this is going to create something that maybe not in 26 necessarily, but it's a good start of a new regulation cycle from the fan perspective watching these cars race?
Let's hope so. I mean, I suppose, fingers crossed. I mean, whenever there's a change of rules, the field is quite spread, isn't it?
Sure.
And that's, I'm sure
it's
that's
inevitable.
I'm sure that'll still be the case. And I'm also sure that over the subsequent 3 or 4 years, it'll close up. But yeah, it's exciting times, that's for sure. That's for sure.
I'm quite excited to see the cars running, being that bit smaller, that bit narrower. I think the current generation do look quite big, feel quite big, particularly at smaller circuits like Monaco. Yet to see, it's not really in our area where the sort of vehicle performance characteristics, that energy recovery, energy deployment, and how that's going to work. How all the teams, will they come up with the same solution? Will they be different solutions? I don't know. I don't know how that's going to work out.
How often are you two in your respective departments pestering this new PU team? Because of course, Oracle Rebel Racing is producing your own engine now with Ford for the first time. You've been a customer team for the longest time. Is it kind of a bit easier from your point of view that you can just you've got a direct number you can just ring up and they're literally in the same building, you can just come on, you can pester them?
Yeah, the information is a lot more to hand, as in it's just a team's call away and we can get that information quite quickly.
Yeah, definitely. Same for you?
Yeah, I mean, as we sort of alluded to earlier, Ed's far more involved in this than I am. For our side, it's more that sort of chassis and that integration, sort of physically the two things mounting together. But again, that sort of regular teams meeting, or even sort of people coming over for face to face. It's a lot easier than if they were based somewhere else in the world. I mean, they're literally just down the road. So
I'll be interested to ask from their point of view whether they like it, because having everyone so close, pestering them, and they can't kind of hide away and do their own thing.
They are in the same time zone as us, which has been a massive improvement.
That's true, actually. Yeah, I can imagine that's a big help. No more late nights, early mornings. So happy days. So talking ahead of this kind of January mysterious test behind closed doors, is that something that will require you two to be there present on location? Would you get value from that, or is that something where you'd get the information fed back to you from the trackside team? It's a long test as well, right? So where's the preparation for you two personally for that test?
I think preparation for us will probably be in car build when the cars are going together. Just it's the first time, all the components will come together at the same time. It's a prototype car. There'll be things that will need resolving, fixing, build orders that maybe not have been thought about during the design process. So there'll be work done before the car even gets to the first test, and probably faults being fixed and new components being designed before it hits the track.
Yeah.
But yes, hopefully I'll be present at the first test for a similar role, just to make sure that the issues that do come out from that test are fed back to the design office for correction and resolution as soon as possible.
Yeah, I'll just echo that really. Yeah, the car build process, and then immediately following that, there's a sort of a rig test that the chassis and engine do in-house, and then that in itself generates quite a lot of faults, which is great because it means it's not happening and not causing downtime when the precious testing days. So yeah, that will be the prep. Exactly that, yeah.
No, because this is as much a sport as it is an engineering challenge, and that is obviously quite unique. A lot of STEM fields don't have that competitive thing built into it, right? Would you call yourselves quite competitive individuals?
Yes.
Yes.
I don't think there's anybody here that isn't.
No.
I think you're in the wrong.
It's a prerequisite, do you think?
Kind of is. I think it kind of is, yeah.
Yeah.
And
it comes out in every aspect of everything we do here, really. Even if it's people in the gym trying to beat each other, it's just going out running, everyone's trying to beat each other.
Gentle runs around the woods. They're not. Well, they start off gentle, and then someone goes, and then that's it. Yeah, it is. It's. I think, as Ed says, it's sort of. It's a recurring theme. I'd say most people in the office, or most people in this company, would say that they are.
Because that's something that I think it's really difficult to get a sense of as a fan, right? We see the trackside team, we see the drivers, we see the team principals, but we don't see so many of the. How many people is it? Oh, well, it's well over 1,000, right? Employed here.
Putting the powertrains to one side, I think it's around 1,500.
Yeah, I mean, it's
easily
a lot of individuals, all very competitive as well. Ed, can I ask about, as chief designer mechanical, what departments kind of sit under your watch, and what's the challenge of kind of choreographing all of those teams?
It's mostly all the mechanical parts that sit within or behind the chassis or within the chassis and under the engine cover. You don't actually see a great deal of what I look after from the outside. It's either hidden by the wheels or hidden by shrouds over the suspension, hidden by the chassis or the engine cover. But as soon as you take the engine cover off and you see all the cooling radiators and the looms and the pipes and the gearbox and drive shafts and everything else, it's all of that really. So yeah, it's just it's been about understanding how those components will change, the requirements that change due to suit the new regulations. So yeah, it's just trying to understand what you can do within the regulations and optimize for that.
And Rich, on materials, I did motorsport engineering at college. Materials and composites was my favourite unit. I loved it. Carbon fibre, Mr. Carbon Fibre, I guess, right? These cars are so carbon fibre. What's the next evolution? Is carbon fibre still the done material for the foreseeable? Is going to be any innovation you see 10, 20 years down the line?
Yeah, I think it's here to stay. I mean, there's a lot of drive within the industry for more sustainable fibres. The downside is that right now they don't have the same properties. They're not quite up to the job yet. You could use them, but you're going to sort of have to put a lot more of it in. Therefore, it's going to be a lot heavier. Therefore, it's not considered. I would say in years to come, I think they'll come to the fore a lot more. How I don't know, but that will be the big drive. I think that's where, because let's face it, there's a lot of waste that comes with using composite materials. It's not just what you see, but in terms of just making the parts. If you looked at the bins outside, it's just full of sort of consumable materials every time a part is cured. Everything just gets thrown away. Not the mold, but all the bagging and all that just gets straight into landfill. So it would be great, wouldn't it be great if in 20 years' time a lot of these cars were made from recycled products or parts that don't have such an impact like that.
And I guess where where the tolerances are so fine, you know, you can't afford to reuse a component that's been in a crash necessarily, because you stick the MRI on it and you see a hairline fracture and then that's in the bin, right?
Absolutely, yeah. I mean, the survival cell is, as the name implies, that can see some big crashes, and that's okay to go again once it's been checked. Obviously, and we do a fair share of repairs in areas where it's all superficial damage is the wrong way of saying it, but it's a repairable part. So that we don't sort of hose through too many of those. Thankfully, it's a big part.
We do try and recover as much as we can from an accident. You know, you do try and work out the loads that those components have seen. You do put them through a series of checks. You know, there can be up to 13, 16 different types of ways to check a component to see if that can be used again. So we do try, where possible, to recover parts.
Yeah, that's true. There's a whole process, isn't there?
And we saw most recently with Gabriel's crash in Brazil, how like the fact that he could just jump out the car just shows how much, I'm sure over both your time as well in F1, how much the safety element has increased and how much more secure these drivers are in the cars, right? It's impressive. It is impressive.
And there's always more being done year on year. Absolutely. The FIA review everything. I think one of the things being brought in for this set of regulations are the lights in the wing mirrors. We've never had to do that before, so that the cars are visible from the side, such as the incident that happened at Spa a few years ago. So they're always reacting to incidents and trying to improve safety.
Oh, it's great.
I was thinking about that crash actually just this morning, because that was one of those horrible moments where he has a sort of side initial contact with the barrier and then a secondary contact, you know, and the worry there is that the front impact structure just gets snapped off and then someone goes head on. That didn't happen. That was great. Not only from it didn't come off, and he went side in, I think, didn't he, after that?
Yes.
But that another small tweak to the regs for the front impact structure for 26 is that it, as well as just withstanding the side push that it does at the moment, there's an additional push off where the forward portion of the nose box needs to fail, and you need to have a section of it remaining, and then that section has its own impact test. So that, as Ed was saying, they do react to every single accident, not just the grave ones, every single accident to make sure that safety standards are improved. You know,
I think it was a couple of years ago at Silverstone, Alex Albon got caught up on turn one, and it was a fairly innocuous contact, but because he got hit twice, it was quite a serious one in the end. And it's very impressive how things are developing and moving on in that front. Gents, we've got some listener questions to wrap things up. Adam from Australia asks, how many sleepless nights have you had, and are you looking forward to testing in 2026? Is it like frantic at the moment, or is it still a bit of a calm before the storm? You know?
Oh, it's not calm. It's not calm. It's not frantic. I mean, you know, but it is we're all fully aware of how much needs to be done, and it's getting pretty tense.
It's the long days and trying to switch your brain off when you get home.
Sure.
And chill. So do get some sleep, but not that much.
Oh, lads, it's only going to get more tense as we get into 2026. Right, Jesse from Canada asks, if you could take a crack at any other position in Formula One, so maybe another job within the team, what would you be interested in trying and why? Maybe a race engineer, maybe a driver? If you back yourself.
I'm happy. I'm kind of doing what I feel play to my strengths. Okay. So in that respect, I wasn't too sure. I'd have loved to have been a driver.
Wouldn't we all?
But I'm sure everybody would have been. Compared to when you see Max, who looked absolute different class in the last race.
Yeah, it's unbelievable, isn't it?
Yeah, probably wouldn't make it.
What do you reckon?
It's a good question. It's a really good question. I think, yes, a bit closer to the cutting edge of it all. So yeah, race engineer, something like that would have been. I haven't got the skill set for it, but yeah, maybe playing into that competitive side, sort of being at every race. I feel like
the intensity of being on that. Yeah, that would be a lot. And then Andrew from Australia asks, how can you transfer what the team has learned about the previous year's designs onto the new regulations?
Yeah, I mean, everything we do really is a bit of an iteration of the previous part. So let's take something like the front wing. Regulations are very different. It's going to look very different. We've got the SLM to integrate, but quite a lot of it from a composites point of view, it is pretty similar to previous. So we're certainly not sort of tearing everything up and not considering anything that's happened before. Yeah. So quite a lot, really, I would say. Certainly from Composite's point of view, they're still composite parts, so you can still carry across all that experience and knowledge. Yeah, definitely.
Yeah, I think it's kind of why I enjoy doing the position that I'm in, is that, you know, I have 25 years of experience and I remember lots of lessons that we learnt the hard way, and it is just reminding some of the newer people that may not want to relearn those lessons and try and guide them through things.
Lads, thank you so much for your time. Really do appreciate it. Two very busy men, so
thank you.
I'll let you head back to the day job.
Oh,
cheers, thank you.
Perfect. Thanks a lot, cheers.
Well, that was a lot we covered, wasn't it? These 2026 regulations, so many unknowns, so much more detail we could have gone into, and I hope this gave you a little insight into what we might see from next year onwards, and I hope you'll be back for Talking Ball in 2026. We will see you next time.